Hi, my name is James McKnight.
Hi, I'm Julia.
I'm Kate.
I'm Emily, and today we're going to be talking about Navier-Stokes and fluid properties with this section of coffee.
Yeah.
To begin, we must start by washing our hands. This step is vital because the soap lowers the surface tension of the water, which allows for a better breakdown of oils across our hands. This ensures that our hands are also squeaky clean, along with ready to brew our coffee.
And right here you can see us making up our coffee. We start by adding espresso into the cartridge there and stamping it down to make basically a packed bed for our fluid to flow through. Then once we've locked it into the chamber there, water will flow through and act as moving through the packed bed in order to make our espresso. The espresso comes out not as a turbulent flow, but more as a laminar flow. You'll see in the video here, it's probably got a Reynolds number below 2000, therefore making it laminar.
Now that we have the completed espresso, we need to clean the cup. To do this, we're going to use a turbulent flow from our sink, meaning a Reynolds number above 4000. This ensures that the cup gets fully cleaned.
Milk is a Newtonian fluid. However, as it heats up, it becomes non-Newtonian, which is how we can change the density of it. Milk has a large concentration of fat, so as it is heated up, the proteins denature, which causes changes in its density. And when we add in air bubbles, this allows the milk to become less dense, which we would need to incorporate into our Navier-Stokes equation. As you can see, the milk being poured is sitting on top of the coffee, so we can see that its density has changed because if it was normal milk, it would just sink to the bottom. But since we added heat and air to it, it is now lighter and is able to sit on top.
This is the continuity equation, and as we can see, it includes density, which is associated with making coffee. Since we have two different fluids with two different densities, that needs to be included. In this equation, we will be using cylindrical coordinates as we are assuming the mug is in the shape of a cylinder. Overall, it is important to note that the continuity equation is important for mass balance.
This is the other equation, which is the conservation of momentum. It applies to making the coffee because mixing the two different fluids allows change in angular velocity as a function of our radius. In this governing equation, we have transient, inertia, pressure, viscous, and gravity forces that are applied. Some of these terms are body forces or surface forces, and depending on the situation, we will not use all the terms. So as you can see, when we put the dye in, it has a lower density, so it stays on top of the milk until it is mixed. And then when it is mixed, it creates a uniform distribution. So once we start mixing, we can see the angular velocity is given from the spoon, and we will also see the radius provided from the cup. So then we can solve for velocity profile.
Now that the coffee is made and the decorative foam is colored, we can see how the different density of the milks allow for the warmer and thermally expanded milk to sit on top of the latte, hence the blue heart seen.
Now you have your nice cup of coffee. Enjoy!